In this video, we're going to look at the concept of work, energy, and power in physics. Alright, so let's begin with work. Now, basically in physics, work is defined as the product of force to the distance of a body. That means work equals force times distance. Work can also be calculated using mgh when mass and height are given as parameters and force is not given. Alright. Also note that when force is inclined at an angle theta to the horizontal, then the work done W will be calculated using force times distance times cos theta, where theta is the angle. When the force is inclined to an angle horizontally, whereas when the force is inclined to an angle vertically, the work will be calculated using force times distance times sine theta. So take note of this difference. This one is when it's inclined, force is inclined to an angle horizontally, whereas this one is when force is inclined to an angle vertically. Alright, so let's solve a typical problem on this before we go to energy. Let's wipe this. Okay, so let's look at this question. It says a ball is pulled 20 meters along a horizontal plane with a constant force of 10 Newton applied parallel to the plane in the direction of angle 60 degrees to the horizontal. Calculate the work done. Alright, so we have our parameters. We have our force to be 10 Newton. We have our distance to be 20 meters. We have our theta to be 60 degrees. Alright, so to calculate the work done will be force times distance times cos 60 or cos theta. When you substitute, then you have work equals, so the force is 10 times 20 times cos 60. Note that we use cos because of the angle is inclined to the horizontal. Had it been the angle was inclined to the vertical, we would have used sine, but since it's not vertical, it's horizontal, we make use of cos. Alright, so don't make the mistake of using cos when it's horizontal in place of sine when it's vertical, right? So don't make that unnecessary mistake. So let me punch this in my calculator. Work will be equals, so I have it to be 100 and work is measured in joules, so to be 100 joules. Alright, so let's wipe this and solve one more problem of work before we go to energy. Okay, so this question says an object of mass 100 kg is released from rest and falls through a distance of 10 meters. What is the work done by the gravity? Alright, so our parameters, we have our mass to be 100 kg. We have our distance, that's, it could be used as, since I'm talking about height, let's use height here to replace distance, 10 meters. And we are asked to find work done. Alright, so we're going to use work done will be mgh, mass times acceleration due to gravity. So acceleration due to gravity here is 10 meter per second square. So since the object raised from rest is falling, right? So it fell and falls through a distance of 10 meters. That means it was responding to gravity. It should not be minus 10 meter per second square. I think it was going up, the object was thrown up, it would have been against gravity. This would have been a negative number. Alright, so take note of that. So we're going to have, when you substitute, we're going to have work done will be 100 times acceleration due to gravity, 10 times, then we have the distance, which is the height here, times 10. So when we multiply through, we're going to have the value to be 10,000 joules. And that will be the answer to this question. Okay, so let's wipe this and look at energy. Alright, so what is energy? Energy is simply the ability or capacity to do work. Alright, so energy equals work done. Alright, and work done is calculated using force times distance, right? Now, the difference between work and energy is that energy is a scalar quantity, whereas work is a vector quantity. Now, we have two major types of energy. We have kinetic energy and potential energy. Alright, so kinetic energy is the energy possessed by a body in motion and is calculated using half mv square, whereas potential energy is energy possessed by a body at rest. Alright, and is calculated using mgh. Now, the relationship between kinetic energy and potential energy, half mv square equals to mgh. So this will cancel this. Alright, so we'll be left with v square over 2 equals gh cross multiply. So we have 2gh equals v square. Make v the solid formula. So this will cancel this. Therefore, v velocity will be square root of 2gh. And this is the relationship between kinetic energy and potential energy. So take note of this expression, are very important in this concept of energy. Right, so let's wipe this and solve some problems. Okay, this problem says that means the kinetic energy of a gear of mass 40 kg only with a velocity of 3 meters per second. So our m is 40 kg, our velocity is 3 meters per second. Alright, then for kinetic energy, the formula is half mv square. So when you substitute, when you input the values, you're going to have half mass is 40, this times 40 times 3 square. So when you simplify, you're going to have half times 40 times 3 square is 9. Alright, so when you simplify this the more, you're going to have 360 divided by 2. So this is cancel, you're going to have 180 joules. So energy, the unit of energy is joules, is measured in joules. Alright, so let's wipe this and solve another problem. Okay, so let's look at this question. It says a ball of mass 0.4 kg is dropped from a height 20 meters. Calculate its velocity at the ground. Alright, so let's bring out our parameters. We have our mass to be 0.4 kg. Okay, we have our height to be 20 meters. We are looking for velocity. That means we are going to use the formula for the relationship between potential energy and kinetic energy, which is v equals to square root of 2gh. Alright, so let me show you how we derive it again. Potential energy is mgh and kinetic energy is half mv square. So m will cancel this m, so we cross multiply 2gh equals v square. To make v the solid formula, you square both sides. This will cancel this. Therefore, v will give you this. Alright, so now let's input the values to be v equals square root of 2 times our acceleration due to gravity will be 10 meters per second square. So times 10 times our height is 20. That means we're not going to make use of this mass. Alright, so it's not relevant to this question since this is the formula we are working with. Alright, so let's simplify. For the v will be square root of 20 times 10 give us 200. 200 times 2 give us 400. So square root of 400 give us 20. Therefore, our velocity will be 20 meters per second, and that will be the answer to this question. Alright, so let's wipe this and go to power. Okay, so note that power is a scalar quantity. Let me say it now before we go to power. Power is a scalar quantity, it's not a vector quantity. Alright, so let's wipe this now and go to power. Okay, so power is basically the rate of used up energy. So energy we used up is power with respect to time. Alright, so it's the rate of using up energy. That means power can be calculated using work over time. Alright, so another way you can represent this, it can also be calculated using mgh over time. It can also be calculated using, depending on the parameters you have, force times distance over time. And it can also be calculated using force times velocity. Alright, because this work is force times distance to give you work. That's why I have force times distance here over time. Work can also be calculated using MGH. Alright, so you can also calculate work using MGH. That's why I have MGH here. And this force times velocity, remember this distance over time or displacement over time, depending on the parameter, will give you velocity. So that's why I have velocity here. Alright, so let's look at how power is measured in watts. So let's look at some examples and solve together. Okay, a rocket, let's look at this question. A rocket of mass 40,000 kg propelled by a force of 1,000 newton acquires the speed of 3,000 meters per second. Determine the power expended, that's the power used. Alright, so let's bring out the parameters. We have a mass to be 40,000 kg. We have our velocity to be 3,000 meters per second, and we have our force to be 1,000 newton. Alright, so to determine the power, remember power is work over time. Alright, and since we don't have distance given in this question, because if we break this down, this formula down, it will be force times distance over time. Alright, or MGH over time. Since we don't have distance or height in this expression, and we don't also have time in this expression, yes, we don't have time. That means when you break this down, you can also give us force times velocity. That means this is the one we're going to work with. So power in this case will be force times velocity, which will be, the force here is 1,000 times 3,000. Alright, so when you divide this, you're going to have the power to be 1,000 times 3,000. You're going to have 3 million. So we're going to have 3 million watts. So this will be the answer to this question. So let's write this and solve one more problem on this before I call it a class. Okay, this question says calculate the power of a pump release 500 kg of water through a vertical height of 4 meters in 5 seconds. Assuming okay, G is 10 meters per second square. So the parameters here, we have the mass to be 500 kg. We have the time to be 5 seconds. Right, so we have the height to be 4 meters, and we are looking for power is unknown. So power will be MGH over time. So when you substitute the value, we're going to have it to the mass is 500 times the acceleration due to gravity given here is 10, alright, times height is 4 over the time is 5. So when you break this down, you're going to have 500 times 10 going to give us 5,000. 5,000 times 4 will give us 20,000 over 5. So when you simplify this, you're going to have the answer to be 20,000 divided by 5 will give us 4,000 watts. Alright, so this will be the answer. So this is basically the concept behind work, energy, and power in physics. And with this, we have come to the end of the class. So let's start interesting. If you are new to the channel, share the subscribe button to subscribe to the channel for more videos. No, like, share, and comment on this video to tell me how you feel, guys, what I've learned. If you seem to have any specific questions, feel free to leave your question in the comment section below. I'll be sure to give you a response. That's it for this slide, guys. Thanks for watching.